So if we take a look at the arm now again, as we have the base, this upper part here, this here and this here, like those two bones here, this here, right? And this here, kind of, not this direction, should operate independently of the rest of the bones. They would kind of aim previously before everything rotates or whatever. But this is kind of different, kind of separate from the rest, just as the base. So we're going to focus on that for now. But this is actually happening after the middle part of the bones. So what I want to do is here a sequence, and let's just make a reroll up here so we remember it. Here is where the middle part would happen, but I kind of want to do the end at first. Just make another sequence here, over here. And I imagine those two also aiming at this position here, because they kind of do. Yes, so the bone D, this one here, if we take a look over here, we can always rotate it to see which one actually is what. This one here would have one axis pointing at something, right? So we're going to grab our D, get it, and we also want to set it. And what do we want to do with it? We want to aim it. So let's use the aim math. Right, the aim math again. We want to aim this bone, in this case, to its next bone, so to E, so get E, and put in the target. So for the secondary axis of this aim here, let's turn it on, make sure it's on. And we want a target for the secondary axis. Now the secondary axis is going to be our control here, so let's get it. And we're just plugging this in here. Make sure you also have -x here. If you now move this around, its main axis will target the bone where it should look, and the secondary axis will just look at this here. I guess we could have kind of made this the base kind of the same, but it doesn't matter right now. It works either way. That way we also don't need to limit the bones. As you can see, it's just like it's looking where it should be looking. Though it's not always going to be this one here. So we are going to copy those 3 node setups here, plug it in, as the target will change, and we also want to interpolate it at the same time. So we are going to do the same thing. We're actually going to make a reroll node in here and in here. I'm just simply going to copy the whole setup. We can copy literally the whole setup here. Yeah, pretty much the whole thing. Delete this here. This is probably the easiest. And plug this into the secondary axis here, target. This is the easiest way of doing that. Right, it's aiming. You can also see this one changing a bit as it's changing to the new target. And the interpolation one, it's going smooth, right? So, all right. Though one thing, for the not interpolated version, I want this to be separate. So I'm going to use, instead of control 1 here, I'm going to use control, yeah, it's a bit annoying. Let's change control 1 to control 2 here. And the interpolation should now be control 3. So this is better. Meaning, so the idea now is that you can use the arm rotation, right? So this is previously rotating, and then you can rotate this here to it. Or if you want something dynamic, you have the interpolation, which kind of does everything interpolated at the same time. Good. Now we want to do the same thing with the last bone here. Essentially, I guess we can just copy the whole setup again, just like the whole thing. So paste it over here and just plug it in. And we want to change those 3 nodes here. First of all, those 2, which bone are we working with? We want the E, so we're going to change D into E, hit OK. And where should it point at? It should probably point at this one here by default. This one is going to point at this. It's E should be pointing at the end actually. So now for this one, we can turn off the secondary axis, in fact, and we don't need a target for this one. This one is relatively straightforward. Maybe we need a target, let's see. Though this one should point at, not at the end here, sorry, at this control actually. So get this and plug it in, right? So now it's directly pointing at wherever this here is. We just need to limit the axis. So we're just going to get our limit axis set up here. Put this in here. We're going to change the bones from A to E, as E is what we're working with, A to E. And we are going to plug this in. Now we just got to check which axis we want. We want the axis Z to still work. So we're going to plug in Z. We are going to override Y and X. And you're going to see if we now rotate this, this one is always looking at this part here. Not so sure why the other one is not rotating. Let me just check up here. There is just simply one that is not working properly. Right, because here we use the initial. And it should not use the initial as the pointed. It should use the current control. This is one thing we have to change here. So, the current control, let's just take a look at it. Yeah, there we go. This is what you should be doing. I think let's just only connect this. I'm going to skip the base rotation here for a second just so I can see if it's working correctly. Control G, I'm moving you a little bit over. You're aiming at that thing here perfectly. This is what I want. And we can connect the rest here. Yeah. So here in the second last aim, instead of interpolating from the initial space here, I want to use the control we have here. Okay, so now we can connect this stuff here again. All right, good. And essentially the bases should be working now. You can see it's perfectly aiming and at whatever it should be aiming. So it's not quite correct yet because the last bone is currently always looking at this part here, which is not quite right. It should also interpolate. And it should interpolate the same way the one before does. So delete this stuff here. And just simply use the interpolate from here to the target and to the upper target. Secondary can be folded in. Now it should work as I want it to. Let's see. You should now be looking completely at the other one. Completely at the other one. Right. And with the interpolate, there we go. This is working as I expected. Very nice. Now we're going to clean this a little bit up and then we're going to move on to the last part here. First of all, we can just simply drag this a bit down here and call this Interpolate, I guess. Simply, this one is also going to be an Interpolate. Simply Interpolate. You can drag this stuff cleaner if you want to. This here is the base rotation, base rot, so like the lowest bone down here where it's aiming stuff, and this one here I call arm roll, I guess, and it doesn't matter, whatever you feel most comfortable with, and arm pitch. Okay, so the bases are done. We can move this stuff now around, right? Yeah, it's working pretty fine. So now the problematic part, obviously, for this whole robot arm is this bone here. Because this bone here, which one is it? It's B. Yeah, B. It's kind of dynamic, or it should kind of follow dynamic. For that, we're going to use CCDIK. So CCDIK, yay. And what we're going to do is we're going to set, let's get a children from the bone B. And we want to include the parent and recursive. Including the parent means just including the one we typed in here. Recursive means it also goes down, not just the children of B, but also the children of C, D, etc. All the children below it. And we can just plug this in here. We need an effector. The effector is going to be our control here. So we just get that one, get, and plug this in here. Now we can drag this around and it's kind of following, but you can see some stuff is breaking and some stuff is not rotating as it should. So we gotta limit some things here. First of all, why did I do this? Not sure why I did this, but let's do it. Set transform and also get transform. And the bone B, we need a bone B in here, B and B. And for some reason I set it onto itself, onto its initial in local space apparently. I think this was to just prevent some error that occurred with the CCDIK or something. Not sure why I did this, but let's keep it in there for a second. And also we want to change the CCDIK here, so from the base rotation limit, let's just type in 360, so we have the full range. And max iterations, we can go a little bit higher, let's use it 25. This is essentially just how many times it like looks for the right position. It's increasing the quality. Precision essentially also does the same thing, but I wouldn't go too low. I think lower is better, but let's use 0.5 or something. Alright, the base problem now is that some things break here. You can see this one is going weird. The other one, this one here is also a little bit offset it seems, or is it? No, it's not, it's by default. This one shouldn't break, but it essentially could if the base is limited. It's not breaking just because the base is rotating the right way. So first of all, we need to limit some bones again. And for that, we just simply, as we did before, can copy our setup here. And we plug it in here. And we're going to change the bone names. So instead of E, we want actually B. So E to B. Hit OK. And which axis do we want to limit for this one here? We only want a Z for this bone here. So Z is already plugged in. The other ones are limited. And it shouldn't really change anything here, but this is just a safety thing, so this other one doesn't break. Alright, next bone. The next bone is C. This one here. As this one here, C, also needs to kind of look at our target. But the problem currently is that the CCDIK kind of messes with it, so I kind of want to kill the CCDIK first. And now I know why I did this. Just doesn't quite make sense. Let's just copy those two nodes over here, as this will allow us to kill the CCDIK. Just we don't want to kill B, we want to kill C. So change it from B to C, and C. Now the CCDIK is completely out there. Right, and the one in the back is not breaking anymore. Right, now this bone here, this part here, should also aim. This one should actually aim at our target. So we need a aim method again. And which one do we want to aim? We want to aim the C bone. So get it, plug it in. Which axis do we want to aim at? If we take a look at C here, it is X. So unfold the axis, X, all right. Where should it aim at? So, and we make sure we have the secondary weight off here. We have C aiming at the control here. So, right now, if we aim this here, you can see, let's just move it up. This bone is trying to aim at it, but we can see there's like a little thing broken, right? So we need our limit set up. So let's just copy our limit setup here. Paste it afterwards here. And the bone we want to limit, we have to change. So from C to D, from B to C, hit OK. And the thing we want to limit essentially is the Z axis, I think is already right. Here we only want the Z axis, the other axis we don't care about. So See, this looks about right. Yeah, I don't care about the other one right now. But this bone is looking at the right point. I did in my previous setup, I used the initial transition here. Not sure why. It might make a little bit more sense to use it, as we don't want to override the position from the CCDIK. But I think it doesn't matter too much. And do we want to propagate to children? It doesn't matter. I'm going to connect the lower part here. I disconnected this earlier. Yeah. We probably do not want to propagate to children here. Set compile. See what's going on. What's happening here is the CCDIK. The CCDIK is kind of messing with us there. Meaning we have to turn off our CCDIK there. To turn off the CCDIK, we already have this setup for that. It is simply this 2 nodes here, setting itself into its initial in local space. So let's just plug this in here. And the bones where we want to turn it off is obviously D. So we're going to change this B to D. And now, all right. And we also want to do this for E. So right click and D to E. I'm just going to like do this like that and make a little bit more space here. So, and you go up here. And then we're doing this part. There we go. Now it's working as I expected to. And essentially that's it. You can see it's perfectly aiming at what it should aim. We are going to make a frame here. Let's just make a few frames here. Kill, I don't know, CCDIK it's usually, but I'm not sure why I set this in front. Shouldn't really make a difference. This is our limit bone setup. This here is the kill CCDIK, kill CCDIK. This is just a simple aim. What do we do here? Yeah, what we could write it out, but whatever. Aim, so. Okay, essentially that's it really, but we're going to make things a little bit finer. Just in case, I'm going to really quickly test things. So this here is our pre-rotation. We can pre-rotate it over here. We can pre-rotate it over here. We can, if we pre-rotated it, we can then use our rotation of zip. There's a little bit of a weird thing there. Some interpolation might help there. We'll see. You can see here's a little bit of a problem where it's, what is going on here? So you can see there's a little bit of a weird thing here where it's like rotating back, right? I think we can fix this by, so essentially what we want is that this point here, or better the point the secondary axis is pointing to, should be closer to its original position. Not by much, but by a bit. Meaning we have to kind of do some math here just for the secondary axis. We're going to use definitely a subtract here. And we want to subtract this, whatever this here is right now. Or maybe just, we see. Whatever this here is, minus the initial from the bone. Where do we set this control? We set this control to the end bone, meaning we need to get our end bone, as this is the original position, the initial. If we subtract whatever we currently have minus this position, we kind of get a distance, and this we want to add on top. So, and then we're going to use a scale. No, not set scale. We want to scale vector, and this should then be the target. If we, let's just see, did something change? Something did change. Kind of want to know where this position is. I'm just going to really quickly make a new space with a new control here. I'm just going to set a space after this here. just so I can see where this here is actually is. So if I now use the control and turn this on, and there we go, this is exactly what I want, perfect. And now I can scale this down to, let's say, 0.5. Actually, not this. What I want to scale down, let's make a reroll node here. What I want to scale down is the change in things. So not really this. Okay, what I want to scale down is this here. Pretty sure now. Scale this down. See, if I scale this to like 0.8, there we go. This is it. All right, let's make like a 0.5 and check this out. If I use this now, you can see the point it's aiming to, this here, is further in the back, meaning it will not flip around as much, as it's kind of in some way respecting its original form still. Perfect. Okay, this is good. Okay, I did way more than I originally did on this whole thing, really. The original thing was way more janky. Reduce aim at vector to avoid flipping. Alright, so there is one more thing we have to do if we now compile this here, and I want you to take a look. If we drag this straight back, it's flipping, right? So we kind of want to try to avoid this error. Now obviously we want to always avoid this perfectly going over the middle here, because this would like instantly flip it. But we can do a few things to, well, help avoid this error. First of all, I wanted to create a new, actually let me show you. The idea is that we interpolate the position of this thing here. That way, or kind of interpolate it. Now what I wanted to do is interpolate rotation, but apparently I cannot figure out how to interpolate rotation, yeah? So, and there's another error. If I try to interpolate this here, interpolate with vector simulation, and I'm going to plug this in. I never experienced this before, and we hit interpolate result here. You're going to see it's just going absolutely bonkers. It absolutely makes no sense anymore. I don't know why. I never had a similar problem like this before, but I'm going to show you a workaround, and at the same time you probably will also learn something nice. So the essential idea is that we are first of all creating a new point here that interpolates. So I'm just going to make a new space here. I already have a few new spaces, don't worry about this, just follow up. And I'm going to call this target interp, okay? Control A, Control Z, enter Control N, F2, Control V. All right, we're going to essentially build our own interpolate, as we sometimes also do in blueprints. Now, if we go to my blueprints here, I already created a variable. If you don't have my blueprints, it's under Window, my blueprint here. We create a new variable, and we call this, I don't know, interp, yeah, interp, or target interp. And make sure if it's selected, you change it to a vector actually, up here, vector. Then we're going to set this, right? And we're just going to plug this in here for now. Now, what do we want to set it with? We want to set it with the new space we created. So get it, and just simply get a position, the translation, and plug it in. Next, we actually want to set the transform. So we kind of want to set it in front. The idea is that a frame later, we are actually setting it, and then we're setting it by itself in some way. You'll see in a second. And now we get our robot end here. So the control we moved around the whole time, right? We're just getting this one here. And now we're interpolating. So we grab the translation and get an interpolate vector, the normal one, this one here. And we are going to plug this right in here. We're going to get our variable, get, and plug this right in here. Now, for everyone who already interpolated in the blueprints, what essentially is happening is we are interpolating from the current to a new target. Actually, this is the wrong way around, sorry, this way around, because now we are interpolating from the current to a new target. So we're setting this space here and writing it, yeah? And then this is the current, this is where it is. And then we are interpolating from whatever it is currently to the new target. And to do this, we also need the delta time delta time. And now if we take a look and move this around, you're going to see that here the little control here, let's make this a bit bigger, like a 5 or so, come on, is actually interpolating. Well, let me select a random, maybe not a 5, let's make a 3. So you can grab another thing. It's interpolating afterwards, right? Pretty slow. We can make this slower or quicker by just simply putting a multiply here in front, multiply. And just simply multiplying it by, I don't know, 5 or something. That should be relatively quick then. And you're going to see this is actually working now. We have an interpolate. This is a very basic thing to understand also for blueprints. So this is very valuable if you actually get your head around it. It's essentially interpolating from the current of the last frame, since this is after this here. This is the current position of the last frame to the new frame. So now we can just plug our rest in here. Hit compile, and now we just have to flip a few things, because now we kind of don't want to target this thing here, but we want to target the interpolated version. For that, you can see I have already marked myself a few things here. We want to plug this target interp control get in here. If we now hit compile, wrong one. Oh, plugged it into the wrong one. It should be right in here. Then you're going to see it's actually nicely interpolating. Though it's a bit broken, this is because we didn't plug it in everywhere. We need to plug it in at multiple points. One would be right up here, where we do the CCDIK after the CCDIK into the aim of the bone C, right in here. Another one would be over here where we do the interpolate for the bone D and the bone E. Instead of the robot end here, we want this one here. All right, that should be it. Yes. Let's hit compile here really quick. And we obviously for the CCDIK need a new effector. This would also be the control of this one here. So let's plug this in here as well. And there we go. Now we actually have an interpolate. Now it's smoothly going in the direction, right? What else do we want? We want, because the problem is it's still going over the middle. Yeah, see this? It's still doing this. For that, I can show you something else. Let's make this maybe a little bit cleaner here. I'm just going to drag this part a bit back, and then we're doing the interpolate right here. Just call this interpolate, and I'm going to delete a few nodes here which we don't need anymore. The thing is, it's still going over the middle, right? We can kind of avoid this by here, after we do the interpolate. Let's drag this a bit nicer here. Exactly right here, we can use a so-called spatial clamp, yeah? And we just plug this in here, and we are going to hit draw debug. We're going to see like a line here, something which represents a plane, but we want a cylinder, and it's the wrong axis. We want to use Z. So what this essentially does, it will not allow the position here to be outside of this. If we hit the minimum, make the minimum, let's say 250 and the maximum 500, you're going to see we have two circles. And essentially what's happening is that our point here, which we're interpolating, is not allowed to leave this area here. And you can imagine this to going up and down infinitely. So if you now drag this, you're going to see it's not going inside here. And if we're going back here, it's like sliding around the side. Yeah. So this is actually a way of like preventing from reaching the middle. It's like a sort of collision in some way, but just a clamp. 250 is maybe a bit much. Let's just use 100 or something. Let's see, maybe 100 is a little bit less. Yeah, let's say 200 maybe? Nah, I don't know. It's definitely better, let's say like a 175 or something. Yeah, you can see now it's maybe still quick and stuff, but it's not like flipping over the middle, right? And essentially now we can go anywhere with it. where we want. Now we're interpolating it, though one thing I want to try, I didn't try this before, here before the clamp. Before the clamp, there we have a node that's just called Reroll Node, which is essentially like a little bit of a jumpy thing. So let's see, yeah, it's jumping a lot now. And we want strength, let's say 25. We just want, like, you can already see it. If I move it and stop it, it's like bouncing a little bit. I want a little bit more dampening, so it's like stopping quicker, like a 0.05 maybe. This is just like figuring out what we actually want to do. Maybe a little bit more strength, like a 50. The numbers are a little bit weird here. I think this is relatively reasonable. You can see how it's like heavy stopping, maybe like a 0.25. Yeah, this is all right. Definitely working, and we have like this little bounce in the end when it's trying to stop. Essentially, that's it. There is not much more we want to do here, as it's working as it should, I said. Okay. Let's just compile this. I want to see something. Okay, yeah, I know why. This position here of our target interp. When we compile, you can see how it's snapping. Why is that? Because this is spawning at 0 and then going up here. So what we want to do is in the setup event, we want to actually set it where it should be. So this here, just simply set. Where do we set this? This is the controls we set. This is essentially the initial here. Let's just set this here. And we want to set the initial to the bone end, just as we do over here. Initial, hit compile. And you can see it's not like going crazy anymore. It's like wobbling a bit. I wonder why. Yeah, go crazy for all I care. It's probably about the, yeah, this is about the frames. You see, when we have more nodes in here, the frames go lower and Mr. Willy goes crazy. Interesting things. Let me just clean things up a bit here. We can now do a few frames here. This is 2D controls. And this one here is set initial transform, and this is just simply temp, I don't know, target. It's just so we set them so we can actually see them. So we should be fine here. So this does it for this video. A lot of thanks again to my Patreons, which is still just shard. Again, if you feel like supporting me and my videos, link in the description. If you want to learn more, I also have a link in the description to my courses. We have some Blender courses about anime. We have a few Unreal courses about shading. If you're interested, just take a look. It's not going to hurt you if you just check it out. And I see you in the next video.